All right, so second type of chemical reactions, of the common chemical reactions, is decomposition. And basically, it is exactly the opposite of synthesis. So all the weirdos you just saw, um, all the other things that we've been talking about still apply. The only thing here is you're starting with a single compound, and then you're going to break down into at least two or more things. So like if you have a dead log and it's sitting there decomposing, it's breaking down from one log into more things. If you build a really cool Lego tower, you start with a Lego tower and you smash it to smithereens. Well, you start with one thing and you get lots more things. Chemically, usually decomposition needs a little help, and typically you either need electricity or heat or some kind of biological thing, because usually chemicals most of the time don't just randomly break apart. Not saying that there aren't some explosive enough to do that, but not typically the case. Same thing, we either have easy or weird, and they're exactly the same as synthesis. It's just that they're backwards. So either you have binary compounds where it's just two elements, and the only thing they can do is fall apart. The only thing I would say be careful with these is that you have to really watch out for your Brinkelhoff, because when things fall apart, you get the elements by themselves. That they can do that. We have the same weirdos. We have metal carbonates, metal hydroxides, metal chlorates, and we have acids again. So we're going to do examples of these. They're the same exact trends. They are just backwards. All right, like I said, it's usually easiest if you go through and identify, is it an easy or a weirdo first. So remember, if you are easy, that means you're just two elements, and the only thing you can do is fall apart. If you're anything more than two elements with decomp, you're probably going to be a weirdo. So that's how we're going to tell. All right, very first one, definitely not just two elements, so he's going to be a weirdo. Second one, just iron and oxygen, so he should be an easy. Third one, definitely, unfortunately, more than just two elements, so it's a weirdo. Fourth one, more than two elements, weirdo. Fifth one, just two elements, so easy peasy. And last but not least, definitely more than two elements, so weirdo. Alright, so once you have them identified, go back and start doing them. Okay, so this is magnesium hydroxide. Magnesium is a metal, so you have to go back and say, what in the world happens to a metal hydroxide? And you just go back in your notes and say, where is it? And say, oh, here, metal hydroxides. They decompose when they're heated, and they give us metal oxides and water. So you know you're going to get your metal, which is magnesium, hanging out with oxygen, and we're going to get water, which we all know is H2O. Now, check your charges. Like, we know water is water, but check your charges. Like magnesium, we all know is +2. Oxygen is -2, so that's okay. Water is correctly written, so that's awesome. We predicted our products. Then you go back through and balance. When you check all your elements, we're already balanced, and you are golden. Second one here is just two elements all by themselves. So what they're going to do is fall apart. So we're going to get iron by himself, and he can be by himself. There's nothing that says that iron's needy or anything, so it's just iron. And we are also going to make oxygen. Now, oxygen is in Brinkelhoff, so we have to put O2. Now, we go back through, we balance. We're going to need 2 of the iron oxide. That'll give us 4 irons and 3 O2s. In case you don't know, iron oxide is the common chemical formula for rust. So anytime you have metal that rusts, that's what you're making. Third one is a weirdo. It's a magnesium chlorate. So you go back through and say, okay, something chlorate. Oh, it tells us here we're going to make a metal chloride and oxygen. So metal is magnesium. Chloride is Cl. And good old oxygen. Remember, oxygen is in Brinkelhoff, so you need the O2. And then again, check your charges. Magnesium is +2. Chlorine is -1. So we need 2 of them. And then once we know we wrote our formulas correctly, we have to balance the equations, and we get a 3. Well, actually, I'll leave these, the sodium carbonate and the gold oxide, for you. We're going to do the last one together, and then I'll give you the answers to these decomp ones, just so you can see if you can get them. But this last one, we've never done one of these before. These are the acids, and if you remember, these guys self-balance, so they are weird. And if you look back at acids, they always make, where'd they go? They always make a non-metal oxide and water, and that's always the case. So just be careful when you do that. So this is an acid. We know it's going to make water. And then you have to kind of count your elements and say, what do I have left? Well, I used all my hydrogen, so it looks like I have a P left. And I had 4 oxygens, but I used one of them for the water, so I have a PO3 left. So that's really all that there is left. And again, this always self-balances for the acids, so that's nice. So I'll pause it. You can try the 2 that we didn't do, and then when we play it again, it'll have the answers up there. All right, and there are your answers for the 2, the weirdo and the easy one. Again, the most important thing with synthesis and decomp are just making sure, 1, you can identify them, and 2, make sure you figure out what you're making first, write those formulas, balance those formulas, and then, and only then, worry about balancing the whole reaction, because you really can't do both at the same time.